Thank you, thank you. So yesterday we talked a lot about the vision of HoloLens, what mixed reality is. We didn't talk an awful lot about implementation and how you take the development tools you use in your day-to-day and use those to create great holographic applications. So I thought that it would be appropriate for today in this kind of code section to talk about what is behind these applications and how you can get started with great mixed reality applications. So to start out with, I'm going to do a little bit more in detail look at the hardware. So the HoloLens is actually a pretty interesting device. Interesting for a few reasons. The first reason is it is fully self-contained. This puts it in contrast with HTC Vive and Oculus and these things which have a tethered cord. Having it self-contained allows you to do some pretty interesting things in terms of collaborating where people can walk throughout spaces. Essentially, it enables a lot of interesting scenarios. But inside that unit is a fully functional computer. You'll notice a lot of the parts sound like something you might have in a laptop. It has an x86 processor. It has a GPU. But in addition to that sort of stuff, it also has some very interesting custom stuff in it. It has something which Microsoft has called the holographic processing unit. This is actually something which they developed in-house as custom silicon, and it does all of the heavy lifting to turn point clouds into these meshes which we see and we will see how to use. In addition to that, it incorporates lots of great sensors. So you see that there's an IMU which provides the gyroscope and the compass and whatnot. It has an infrared depth sensor which can project out 120 degrees. It has webcams, microphones. All in all, there's a ton of hardware in this unit, and really it's up to us to unleash the potential of it. But let's talk a little bit about the platform. So as you might imagine, it runs Windows 10, and that's actually a pretty important realization, because once you realize that, you'll realize that it is not this platform which came out of nowhere. It has access to everything that the Windows platform provides, and that includes things like stability. You use the same Windows core as your laptop uses, so that it's going to be stable. And in fact, any UWP application which you've written will likely just work. There's a few, I put an asterisk there because there's a few small things about file pickers and things like that, which are a different contract. But 95% of UWP applications will work straight out of the box. It allows for XAML. It allows for DirectX. It has some great security features built in. All of the features which you are used to in writing UWP applications just come out of the box with the HoloLens platform, which is really exciting. So let's go and talk a little bit about what are the tools that you use to create these holographic applications. So the first tool that you use, and if you've spent any time doing VR, you might recognize Unity. Unity is a game development platform which is cross-platform. It can be targeted towards iOS, Android, Windows, and indeed the universal Windows platform. So what is interesting is that there actually is a special build of Unity specifically for HoloLens. In the future, it's going to become a plugin, but for right now, it is a special build. So what that build gives you is the links to the HoloLens, and specifically some links to allow the camera to track with your movements. So a lot of that comes out of the box, and as long as you use the Unity for HoloLens with holographic extensions, you'll get that stuff out of the box. So it includes some great things. It includes the ability to access the spatial mapping information. It includes some great spatial audio support, as well as a few more extensions to allow using universal APIs, such as the holographic ones. So the next part of your dev kit, and again, this is probably pretty familiar, is Visual Studio. So Visual Studio, remains the key to creating packaging UWP applications. What's interesting is that for Windows Holographic, you don't need to get professional edition and whatnot. There is actually a community edition of Visual Studio, which works perfectly fine, and is obviously free for cost. So using Visual Studio gives you lots of great goodies, as you might expect from Visual Studio. You can do remote deployments to devices. You can even do remote debugging, where you can look around and hit breakpoints in your code. All in all, you get the same experience that you're used to in Visual Studio, but that's what you use. The next tool that I'll point out is the HoloLens Emulator. So when Microsoft released the SDK, they realized that, hey, not everyone's going to get a HoloLens immediately, and indeed, in Poland, it's actually pretty hard to get one right now. They only sell them in North America, and we've shipped it over from our Canadian office. So what they've released instead is the HoloLens Emulator. The HoloLens Emulator, to get technical, is a Hyper-V instance which just runs on your computer and is an exact hardware copy of what the HoloLens is. So this is pretty neat. It allows you to do testing of your applications. It allows you to simulate rooms and spaces, and indeed simulate any of the tracking events which come from the HoloLens. So this is a tool that, even if you have a HoloLens, is something you use pretty often, and it is great for testing the gaze, gesture, voice. It's great for testing different room layouts without having to physically leave your desk. It's good for moving the camera around. It's not good for some things, and indeed, you do need to run the HoloLens at some point. And specifically, what those tend to be are things which relate to scale. So it's very hard in this image here to see, whether those sofas are, is this a dollhouse? Is this, my living room? It's hard to gauge those sort of metrics. So generally, what our process is we will run it, run the first copies in the HoloLens just to get an idea about scale and whatnot, but after that point, we can use the emulator, and it's a much more streamlined process actually to deploy to. So the next thing is the device portal. So if you've spent any time with Windows 10 IoT or any of the other kind of products from the Windows 10 device family, you might recognize this. So this portal is actually a website which is being hosted by the HoloLens at all times. It allows you to do some pretty neat stuff. I'm going to go through kind of each page and what you can kind of expect from it. So this is the landing page. It relies upon you logging into it and whatnot, so there's some security around it. The only thing that is to note here is the interpupillary distance. So as John mentioned yesterday, there is a notion of calibrating the HoloLens. So if it is your own device, there's actually a small application you can do to run it, and you simply place your finger at certain distances so it can just understand how close or far apart your pupils are. If you happen to know that, and you can ask your optometrist if you really want, you can enter this distance here. Generally, this range from 62 millimeters to 68 millimeters, and you simply enter it here, and then it optimizes the experience. If you don't do that, and you have particularly wide-set eyes, you might get a headache from it, but most of the time it's pretty safe. The next thing, and I wish I had a picture of it here, is the mixed reality capture. So this is actually what we showed yesterday. So using mixed reality capture allows you to view what the person with the HoloLens is seeing. So through here, you can do live preview, you can record, you can take pictures. It's great for demos and whatnot. The next one is 3D view. So if you want to understand what the spatial mesh is in the HoloLens, this is a great tool. And it allows you to download the entire spatial mesh from the HoloLens and see where the camera is and just be able to understand why your particular tracking events are happening. And then the last one, which comes into play when you're trying to optimize your experience, is the performance view. And this allows you to understand whether you're running at 60 frames per second, how much power you're using, for battery life. It's a great tool to kind of determine your performance. So in terms of building, it's a very straightforward process as well. So as I mentioned, your primary tool for doing HoloLens development, unless you want to do DirectX, is Unity. So within Unity, you create your application as per normal. But what is interesting is that, as I mentioned, it's a cross-platform, development tool. You can export to a Windows Store application. So from here, you can specify that you want to export to a universal Windows 10 application running Direct 3D. You do that. And what it gives you is a Visual Studio solution. What's interesting about the solution is that you can add whatever you want to here. So if you want to bring in some of your own custom NuGet packages, you want to bring in a lot of enterprise stuff, you can put it in here and it'll run full Windows. And from here, simply deploy to the HoloLens. You can deploy it via USB, or you can deploy it via Wi-Fi with a pin. So the next thing I want to talk about is the Holo Toolkit. So Microsoft in the past few years has certainly taken a shining to open source development, and this is a great example. So the Holo Toolkit is actually two projects which are hosted in GitHub. So one is a C++ project, and this is kind of all the low-level details and kind of libraries. And then they have a Unity project, which uses a C++ project in order to hook these up to Unity prefabs and scripts. So there are lots of goodies in this toolkit, including things like the sharing server, which I'm going to talk a lot about in the next little bit. It includes spatial mapping, sound, gaze, gesture, voice. And our guidance is that before you go and do something by yourself in the HoloLens, check the Holo Toolkit, because the majority of the basic things that you want to do in your application have been programmed here, they have been peer reviewed, and it's actually a really vibrant community developing this toolkit. We have a couple of people in Infusion who are pretty active contributors, and there are probably hundreds of people contributing to this. And to that point, I do encourage all of you, even if you don't have a HoloLens, to take a look at it and get involved. There is a forum at hololens.com. There's a list of issues, enhancements suggested there. And I can certainly tell you from going to Redmond and interfacing with the team, this is their primary kind of interface with the community. So it's very easy to get someone, talk to someone from the actual team, talk to someone really deep into it. So I would encourage all of you to take a look, and if you're doing HoloLens development, consider contributing to the Holo Toolkit. So that's your kind of basics of development. So what I want to talk about now is, how do you use gaze, gesture, voice? How do you, get started with these concepts? So there's a little bit of a refresher from yesterday. So the first concept of HoloLens is gaze. So gaze is really what you're looking at. This is the context of your operation, and is centered in the user's view. So in HoloLens, this is implemented, with three ideas. The first of which is camera tracking. The second of which is, object selection. How you know which object is selected within your scene. And then the last one is cursors. So to talk a little bit about it, it makes it, again, the Holo Toolkit makes this very straightforward. So within the Holo Toolkit, there is a class called the Gaze Manager. So the Gaze Manager simply has this code snippet in its update statement. So for any of you who have Unity experience, you'll recognize that what it's doing is a ray cast, and specifically how it's doing it is it's taking the camera's origin and direction and shooting a ray through the scene, looking for the object which it intersects with. So this is something which is done 60 times a second, or whatever the game is updating at. And from here, we get an object which is simply focused object. So the Gaze Manager is a singleton, so if you want to understand what is being selected, you simply have to ask Gaze Manager.FocusedObject. So the next part of the puzzle is the camera. So how does the camera position get tracked? So the answer to that is kind of magic, and it's encompassed within that Unity holographic, which I mentioned before. So if you use the holographic extensions to Unity, you don't need to worry yourself with that. The camera will update its position. And then the last one is the cursor. So in desktop applications, we're used to cursor as a little arrow. Within holographic applications, the guidance is that it should be something which hugs the surfaces in your room or the holograms. But it's up to you to implement. So generally, we use toruses is our favorite, and you can use the gaze manager's position and normal that I show up there just to position it. Next one is gesture. So gesture is your selection action. So you just use an L and tap it down. So two ways that works. First, there's the gesture itself, and then there's manipulation. So the HoloLens does understand movements of your hands, but again, using the Holo Toolkit, very straightforward. So gestures simply has a gesture recognizer, and it is able to listen for tap event. And what's interesting is that if you have a 2D application, these actions are automatically mapped as well. For manipulations, again, very straightforward as well. So you can listen, set up your gesture recognizer, listen for particular types of manipulations, and you get callbacks when the event, when it starts, when it updates, and when it completes. So again, very straightforward. And if you look at any of the samples, you'll see great examples of this. The next one is voice. So as we mentioned yesterday, voice is a first-class interaction within the HoloLens, and generally we suggest using one of two techniques. The first one is a keyword recognizer. So simply said, you just instantiate this recognizer with a set of keys, and once one of those keys has been heard, it will send a callback. And simply, there's an on-phrase recognized event. The other type is what we call dictation. So dictation is something which relies upon internet connectivity and uses the same voice recognition capabilities of Cortana. So when you start this recognizer, you are given these callbacks which allow you to get the results. It allows you to get hypotheses as the person is saying something, and then errors and completes and whatnot. So generally, when we're using this one, we just listen for the dictation complete, and once you have received this, you can get all of the plain text of what the person was saying. And then the last one is spatial mapping. So spatial mapping is creating this great 3D mesh. So it's done with a couple things. There's a spatial observer, which creates a series of spatial surfaces. So generally, again, this is implemented within the Holo Toolkit, and the flow is that you can create a spatial observer with a volume around yourself. You can say that I want meshes within 3 meters of yourself, and it's centered around yourself, and it will simply return you meshes and points which fit within that sphere. You can do so using polling, you can do so via events, and again, you just need to add or remove these surfaces from your understanding and Unity to make this work. And again, this is all implemented via a lot of the Holo Toolkit classes. Oh, I guess I have one more. And spatial sound. So spatial sound is the ability to project 3D sounds into your world. So again, this within Unity, this is fairly straightforward and very similar to how you do it on Gear VR or Vive or whatever your platform is. So when you put a sound within Unity, you get this nice thing here, and there is a property called spatial blend, and you can specify whether you want the sound to be 2D or 3D or a mix of the two. So simply use that, and the sounds will appear from the correct place. So I want to end off on how to using those building blocks. How do you create a great application, and particularly one which is a shared experience? What we found is that shared experiences tend to be the most powerful because they allow multiple people to see the same holograms, and they allow for auxiliary devices to kind of connect to the experience and control it. So. And then this is a little bit more complex than some of the samples you might find, but it is kind of a real line of business application. So when we think about a shared experience, we think of it as kind of a triangle of needs. So at the top, we have the application. So this is what I've been talking about. This is the Unity application compiled to UWP and whatnot. The next to which is how do you get the models into the application? So for simple applications, sure, you can just embed them into Unity directly. But what we found is that a lot of real applications, there's a need to load models at runtime because otherwise, your application is just very static. So we're going to talk a little bit about model providing, and then obviously you need networking support. The device has great Wi-Fi, so that helps with that, and then shared coordinates, and then avatars. So generally how this is set up is that we have all of our devices, be it HoloLens, be it VR, and they talk to two different services. So first of which we have our collaboration server, and this is actually provided by the Holo Toolkit. The second of which is our model provider. So by using these two services, we are able to kind of complete that triangle over there. But again, let's talk a little bit about each in specific. So the application, I think I've talked about enough. You build through that sort of process. But the next is the model provider. So as I mentioned yesterday, there are a lot of restrictions around the HoloLens, by the virtue of the fact that it's self-contained. And what it means is that it uses an Intel Atom chip. It can only handle certain complexity of models. So what we found is that when you're using models in Unity, the total visible polygon count has to be less than about 150,000 at all times. Otherwise, the experience just becomes unacceptably slow. And in addition to that, individual meshes have to be less than 64,000 polygons, and this is more of a restriction on Unity. You can break up your models into multiple meshes, but the 64,000 is pretty nice because of what it means is you can have two of these objects on screen at a time. So when you're importing these meshes, you should check to see, could the polygon count be substantially more than that? And if it does, then we need to decimate the mesh. There are a number of solutions for this. You can roll your own, but we tend to use a product called MeshLab, which has a nice server component. So the process is, generally, when you upload your model from whatever source, you count see how many polygons there are, you decimate them down to what you need. You might need to optimize the textures if they're particularly large, and then you can put it in your model store. This could be file storage, it could be a SQL database, whatever. And then on the client, on the HoloLens, when you issue this model request, you can simply retrieve from persistent storage, and then you can programmatically import this model into your application. So pretty straightforward. So the next part of the equation is the network. So as I mentioned, the Holo Toolkit provides some great tools for this. It provides specifically a server component, which can be hosted on PC or Mac. It has some great things such as a room manager. So this manages all the physical spaces your experience is using. It has a session manager, which is all of the different shared experiences which are going on at a time. And then it has a message bus, which is available via both TCP and UDP, and it also supports auto discovery. On the client side, there are libraries available for pretty much all different platforms you might want to use. It is written in C++ initially, but it is exported to Unity, is exported to .NET, and it's what you use for all of your applications to hook up to it. So a few tips. Do use the auto discovery because otherwise you might find you have hard-code IPs, which is not really maintainable. There are some tools provided by the Holo Toolkit, such as the session manager. This enables you to understand all the people connected to your experience. And then when you're kind of designing your messages, make sure that you consider the performance of it. Make sure you're not flooding the network with things like position changes and whatnot. The next part of the equation is coordinates. So when you have two experiences running and wanting to view the same hologram, it's important that they share the same coordinate space. And because every HoloLens is self-contained, it is running its own copy of the application. And more so, it has its own coordinate system. Each HoloLens might view the room at different angles, and there's no guarantee that the spatial mesh will be remotely similar. So Microsoft has put in a great feature in the HoloLens, which they've called a spatial anchor. So what a spatial anchor is tracking information which allows you to define a physical space. This is generated by the holographic processing unit and is serializable. So when you load this into both your own HoloLens as well as other HoloLenses, it's able to locate this space and then align internal coordinate systems to that. And more so, it automatically adjusts to match the real world. Oops. And a few tips. So do place these anchors wherever the user places the object. Keep your objects within 3 meters of these anchors, and don't make too many of them, because if you make a grid, hundreds of them, it becomes computationally really expensive. So the last thing that kind of is part of the puzzle is state. So state is very important within games, and it's very important within shared experiences. So you need to communicate a lot of state. So part of the state is the position of different headsets, because you often want to have things like, know what this remote attendee is looking at. You might have state of, what map is loaded. So these are typically broadcasted over UDP to all the different clients. And again, as I mentioned, it's very important that when you're designing these messages, you kind of optimize to make sure that the frequency of messages isn't too much for the network. These messages, as I mentioned, might include headset positions, any gestures performed, anchors used, as well as game state. So I hope this gave you a quick introduction to HoloLens development. There are a lot of great resources available. If you go to hololens.com/developers, you can get links to all of these. There's great tutorials, there's the HoloLens Toolkit, and really everything you need to get started with holograms. Thank you for your time.